All right, so today's lesson is going to be on climate. All right, now you've probably, you talked about climate like what, grade 5 science. You probably talked about it again in junior high. Okay, we're going to go into a little bit more detail about some of the things that will probably be familiar to you. Okay, you probably talked about what kind of things, are part of climate and what kind of things affect climate, but we're going to go into more detail about those components and factors, okay, today in terms of this, because what we're looking at in this unit is how things work on Earth in terms of energy and matter, okay, and kind of how they interact. All right, so we're taking some of the stuff from the chemistry unit, we're taking some of the stuff from the physics unit, okay, and now we're putting it into a real world, or not so much real world, but natural world kind of situation. All right, so when we talked about the laws of thermodynamics in Unit 3, we're going to be using those now, but in a different context, not from, oh, this glass of hot water to this glass of cold water. Now it's going to be from the atmosphere to the ocean, or vice versa, or from the sun to the earth and things like that. So we're using those concepts, but now in a different context. Okay, everyone kind of follow me there? Right, so that's why this unit can be quite short. We're not learning a lot of new stuff, we're just applying it to different things. Okay. All right, so what we got to go over today are, first off, the components of climate. Okay, when we talk about climate, what are the things that we would include in a description of some place's climate? Okay, then we're going to look at the factors that affect climate. So it's important to keep those two things straight. Okay, there's the components or parts of climate, and then there's the things that make climate the way it is. All right, so why our climate here would be different than in Brazil. Okay, those, there's different factors there. Then we're going to look at the effect of climate on plants, animals, and humans, very, very briefly. Okay, describe energy inputs and energy outputs. Okay, what's essentially for 99% of all ecosystems on Earth, the input energy source is what? The sun. Yeah, okay. There's only a very few like kind of deep ocean benthic environments that run strictly on an input of chemical energy. Okay, and then we're going to look at climatograms. Okay, climatograms are a tool that we use to show the climate of an area and can infer from those the factors that are affecting that climate. Because we'll be doing an activity this week, okay, on using climatograms, interpreting them and such. All right. So if we're talking about climate, if we turn on the weather in the morning, what are the things we want to know? How cold is it going to be? Notice it's winter. When I say this in May or June, people say, how hot is it going to be? Okay. How cold is it going to be? What else? Is there going to be precipitation? Yep. Okay. What else? Yeah, is it going to be windy, especially here, right? Is it going to chinook, or is it going to be really, really cold? And one other thing. Yeah, it could be cloud cover, and also you'll find that in the daily report, like if you open any of your weather apps, whatever, they'll usually tell you sunrise and sunset or number of hours of sunshine in the day. Okay, those are the components of climate because they're the components of weather. Okay, all climate is the prevailing weather conditions at a location. It's not the average. People get that confused. Okay, people always say, "Oh, the climate's just your average weather." Okay, well then the climate of Okotoks is that it's 4 degrees Celsius. The wind is from the southwest at 25 kilometers per hour. There's 12 hours of sun and 12 hours of darkness, okay? And it'll rain less than 1 millimeter of rain today. Is that an accurate description of what it's going to do here? No, but that's the average, okay? If I averaged out the 4 factors affecting climate, or 4 components, sorry, of climate in Okotoks, that's about what they would be. Okotoks is dry. Okotoks is consistently windy from the southwest. Okay, and I could say for anywhere on Earth, there's going to be 12 hours of sun, 12 hours of night. Okay, because that would be true on average. Everybody with me on that? Okay, so obviously we don't want to describe it that way. Okay, we want to describe the climate of Okotoks more in a what can we expect kind of a thing. So we could say, if we're describing the climate of Okotoks, that Okotoks has temperature that varies significantly due to its seasons, right? The temperatures can range anywhere from -35 to +35, okay, depending on what part of the year we're in. Okay, rain or precipitation can come in many forms. Okay, during the winter months, precipitation will fall as snow, but doesn't account for a lot of moisture. Okay, the wettest months would be like June. June and July are typically our wettest month, June usually being far wetter. Okay, and most of our precipitation falls during that time is rain and hail. Okay, and then the wind, it is typically from the southwest. Okay, we get specific wind patterns called Chinooks that people like Leonardo DiCaprio don't understand. Okay, and they can cause rapid changes in weather, not climate. Okay, see, this is why this is important. You don't want to look dumb on Twitter. Okay, because when you say you witnessed climate change firsthand, you sound dumb. Why? Climate's always changing, but climate change is gradual. You can't witness climate change in a 3-hour period. You can witness weather change in a 3-hour period. That's what a Chinook can do. Okay? That's why we have the expression in Alberta. If you don't like the weather, wait 5 minutes. Because it changes all the time here. Okay? We do get rapid changes in weather. So that's how we would describe climate in Okotoks. We don't want to give an average. That's not an accurate description of what it does here. Okay? All right, so major components: temperature, precipitation, light, and wind. So these are the things that can affect our weather, and obviously they vary quite a bit. Okay, our driest months tend to be like October, November. Okay, those tend to be our driest months of the year. We tend to get more snow December, January, February, March. Okay, and then kind of the spring months are our wettest. Okay, months typically, especially June. And then July, August, it starts to taper off, things like that. Now, light. We're one of the sunniest locations in Canada, okay, where we are. But does the amount of light and the quality of light we get change throughout the year? Yeah, like right now, we're approaching our shortest day. Okay, December 21st will be the winter solstice. That'll be the shortest day of the year for us. Why do the days get shorter? Okay, partly the position of the Earth as it goes around the sun, but also because the Earth's axis is tilted. Yeah, okay, it's totally the fact that the Earth's axis is tilted that causes us to have season, causes us to have changes in length of day. Okay, now if you're near the equator, do you notice that? Not at all. Okay, I remember distinctly I was in Hawaii one time, and the tour guide was complaining that they were only going to get it was 11 hours and 5 minutes of sun today. And I'm like, are you kidding me? Like your day fluctuates from like 11 hours to 13 hours over the course of a year. Okay, like you don't even notice that. So come to Canada in December and live through a 5-hour day. Okay, 5 hours of sun and the rest of darkness. Mind you, it's also going to be minus 30. Stop complaining. Okay, because people don't understand that in an equatorial location, they get about the same amount of sun all year, and it's directly overhead, and it's very intense. Okay, whereas for us, when we're tilted away, the sunlight is less intense. Okay, so things like that. So we'll look at that. But light is certainly a factor because light drives weather. Light's the source of energy that gets the water cycle going and can influence wind and all of that kind of stuff. Okay, all right. Now, what do we see here? What kind of cloud is this? Now you got to remember your grade 4 weather unit. Cumulonimbus cloud, right? The big thunderheads that we get in June and July, and then they dent all our cars. Anyway, this is a cumulonimbus cloud, okay? It does. Well, cumulus, mature, dissipating, but yeah, close enough. So a thunderstorm is a good example of the interaction between the components of climate. Okay, the components all have to be just right to produce a thunderstorm. Okay, we don't get a thunderstorm every day. Okay, we can get into a cycle where they happen often, but we don't get them all the time. Okay, because there has to be a fair amount of energy to build one, which means we don't get them in the winter. Okay, it's incredibly rare to have a thunder flurry. It has happened. Okay, I can't remember where, it was on the Weather Network one time. This weather guy, he was just about to retire, been doing the weather for like 45 years, and he'd never seen a thunder flurry, and he was in one. And the guy was going ape. Like he was just going nuts because he was seeing a thunder flurry. As a meteorologist, I guess that's a big deal. I don't know. Even as a nerd myself, I've seen kind of an extreme reaction, but whatever. Okay, it was snowing and there was thunder and lightning, and it was pretty different because you don't normally see that. Okay, and he was just like running around, literally, like he dropped the microphone and the camera was just following this crazy man running around about how excited he was over this thunder flurry. But it doesn't happen very often because you need a lot of energy to build a thunderstorm, which usually means you're not going to get snow at the same time. Now, we do get hail, oddly enough, though. How do you get hail when it's a hot day and it's built this big thunderhead? Well, it's sort of wind. It's a cyclic thing. Yeah. Okay. So during the day, like it's got to be a humid, fairly calm, hot day to build a thunderstorm. Okay. And what happens is you start getting water vapor that evaporates and moves upwards. But as it moves upwards, it cools. Okay. And when it cools, it condenses, right? So it starts to fall back down. But what happens is you've got so much water vapor and warm, heavy air moving upwards that condensation actually gets forced back up into the cloud. Okay, so you've got liquid water now that's being forced higher up into the cloud with more water vapor condensing. So you go from having like tiny droplets to having bigger drops. Okay, those bigger drops get heavy enough that they start to fall. But there's so much warm, hot air moving upwards that even large drops of rain can be forced back up into the cloud even higher. So that's why we see during the day, we see the thunderheads get taller and taller and taller. Okay? And eventually their tops are well above the freezing point, and these now big raindrops become hailstones. All right? And you can actually see this process of deposition on a hailstone. If you ever, next time it hails and they're big enough, hopefully it's not soon, but okay, just go out and break one. You can actually see layers. It looks like an onion, okay, on the inside. You can actually see the layers of ice deposited on the hailstone as it grows, okay, throughout this process. Okay, but like I say, it's an interaction. These components all have to be just right to produce one of these. Okay? And if they get really extreme, you have so much air aloft and so little down below that you create a massive pressure difference that will cause a a tornado is trying to balance a massive imbalance in pressure. Okay, there's lots of pressure above, very little below, and it pulls it down. Okay, and starts a rotation, okay, that well, can be quite destructive. How many people have ever seen one up close? Okay, one of the scariest things you can experience. Okay, yeah. Like they're scary. I actually hid in a culvert one time because of one. Okay, like dove into a slough, like water-filled culvert. Okay, which later I've discovered was probably not the smartest because you can get sucked right out of them. But that's where I went. Well, yeah, I mean, it's better than being out in the open where you can get impaled with stuff, right? I just wanted to be sheltered because I didn't want all the flying. That's what kills most people in a tornado, okay, is they actually get impaled. And they get hit by stuff that's being thrown around by the tornado. So yeah, they're quite dangerous. They're quite scary. Lightning's also quite scary. You ever been close to a strike? Yeah, like I've been close lots of times because I used to work at a golf course. So you're like driving around on this big piece of metal, and you got your headphones on because you don't want to damage your ears from the sound of the machine, so you don't hear the thunder. And if you're not looking, you're looking where you're mowing, you don't see the lightning flashes either, okay, until one hit the flagpole, okay? And I was like, holy crap, I just jumped off the machine. It just kept going, cutting a big strip right down the fairway. I jumped in the bunker and waited for my boss to come get me. Okay? But yeah, they can be pretty scary, okay? And if you've ever been close to one too, like you'll see the hair on your arms everywhere will stand up, okay? Like we had one at a track meet one time, okay? And all the kids were laughing and I'm like, what are you guys, oh my God, everybody just lay down on the ground right now because everyone's hair was just like way up. It was crazy, okay? There's massive lightning strikes and stuff, so yeah. And don't climb the football standards then. Well, someone was climbing. I'm like, get off of there. Are you nuts? You're going to die. You're going to get like cooked onto the pole. You'll be a person kebab. Okay. Yeah. You don't want that. Okay. All right. So all of those factors can produce, okay, or all those components, okay, interact. They produce the conditions that we're familiar with. So when we describe the climate of an area, those are the four things that we're concerned with. What does temperature do over the course of a year? Place like here, it varies a lot. An equatorial area, it doesn't vary very much. Okay, Precipitation. We describe what happens over the course of a year. There's wetter months than others. We get various forms of precipitation. We describe that. Light. We talk about what happens to light patterns. Do they change? Do they get about the same amount of duration and intensity or not? And then wind. We typically describe that in terms of direction and intensity. All right. Factors that affect climate. And we're going to go through a bunch, and we're going to do them kind of in order of importance in general. Okay, at least the first two for sure affect any place on Earth. Okay, so the most important factor affecting climate is latitude. Okay, where you sit on the Earth in relation to the equator is the single largest determining factor for your climate. Okay, and the reason for that is it determines the amount of solar energy that you receive. Right? So, because the Earth is round, by the way, the Earth is round. It's not flat. That's what crazy people think. Okay? The world is round. Okay? We know this because we've orbited it. We've seen it. It's really round. Okay? Okay. And see, these are the kind of arguments you get from flat Earth people. Anyway, so what we have here is a round Earth that is also tilted, all right? But we'll look at it in this orientation right now. That is the orientation where it is straight up and down, which is actually only the Earth's orientation how many days a year? 2. Okay? The Earth is straight up and down like this 2 days a year. Which 2 days? The equinoxes, March 21st, September 21st. Okay, those are the equinoxes. So, okay, those are the days where we're straight up and down. So, depending on where you are on Earth, okay, the sun strikes that part of the Earth differently because the Earth is curved. So, all of these yellow bars represent equal amounts of solar energy. At the equator, this amount of solar energy strikes an area this big. Okay? As we move away from the equator, because the Earth is curved, that amount of solar radiation spreads out over a larger area. Okay, so when I drew this line, this black line down here at the equator, it covered the entire area. Now it's short. So that same amount of sun is hitting a larger area and is, as a result, less intense. Okay, so it's going to be cooler in that place because the sunshine isn't as intense or direct. Okay, and it gets worse the further away you go. Right, that same amount of sunshine is now covering an area almost twice as large as it was at the equator. Okay, everybody with me there? Now, this is exacerbated by the fact that the planet is tilted as well. So right now, instead of being like this and having this amount of sunlight hit North America, we're like this. Okay, we're tilted. It's two-dimensional. It's still round, but I can only draw it two-dimensionally. Okay, now, right now, we're approaching the maximum amount that we will be tilted away from the sun. So the sun's light hits the Earth like this. So when the Earth is rotating on its axis, this line here, we don't get into the sun nearly as much, which is why the days are shorter. Everybody with me there? Okay, like we spend more time in the dark. And we're tilted away, so that same amount of sunlight is now hitting an even larger area. Okay, meaning it's more, it's not more, it's less concentrated than it was in the diagram that we saw. The opposite is true on the summer solstice. On the summer solstice, we're pointed like that, towards the sun now. So when the Earth rotates, we stay in the sun for a lot longer. If you're at the North Pole, the sun never sets. In fact, if you can trace its path, it just goes in this little circle around you because you're rotating and not getting out of it. Okay, so if your mom says come home at sunset, you can come home in September because that'll be when it sets. It'll be above you all the time. All right. In this case, now look where we are. Now we're almost in the very direct sunlight because we're tilted now towards the sun. So in the summertime, it's hotter, not just because we're in the sun for longer, but because we're more directly pointed at it. so we get more intense sunshine during that time of the year. Does that sort of make sense? Okay, so that's how latitude can affect climate. That's why latitude is the #1 factor affecting climate. It affects all places that way. If you're near the equator, that tilt of the Earth doesn't change very much, or it doesn't affect you very much. Okay, so essentially, if you're between the Tropic of Cancer and the Tropic of Capricorn, there's virtually no difference. Okay, anything above or below those latitudes, then you're going to start to see significant difference. All right. It's also why we have daylight savings time. Okay, we need daylight savings time here in order to account for the fact that the days get so short, okay, that we need to make sure we're awake when it's light. Okay, and especially if you're a little kid waiting for the bus or walking to school. Okay, we do daylight savings time. That's actually the main reason we have daylight savings time, is to make sure that it's light as long as possible when children are on their way to school. Okay, in the wintertime. Okay, in the summertime it doesn't matter because the sun comes up at 4 and it goes down at 11:30. It's awesome. Okay, but in the wintertime it's the exact opposite. Okay. All right, so is that sort of making sense to everybody? Okay, because I have a lot of people, they'll tell me that the reason that there's seasons is because the Earth gets closer to the sun. Which, the sun's not flat, no. Okay, so what they're saying is that the Earth's orbit isn't perfectly round, which is true. It isn't. The Earth's orbit is actually an ellipse. So there are points in the Earth's orbit where we're closer to the sun than others. Okay, but believe it or not, when we're closer to the sun, it's actually in the wintertime for us. Okay, but the Earth's orbit is not perfectly circular. It's also not shaped like this. But you get the idea. There are times when the Earth is closer to the sun than others. Okay, what causes the seasons for us is that, again, that tilt of the Earth. So the Earth's axis is tilted like this. Okay, this would be an equinox. This would be an equinox. Okay, these would be the solstices. Okay, so the Earth's tilt stays the same. It's just where we are in the orbit that changes whether we're in the sun more or out of the sun more. Okay. All right, which season's the shortest? Fall. Second shortest? Winter. Okay? Yeah, and the reason is because the Earth moves faster in various points in its orbit. So, okay, it's not spending, there's times where, okay, like when we're out here, the Earth moves faster through this section of its orbit, so this section of the orbit is shorter. Okay, well, that's how we make the calendar work. Yeah, okay. It has to do with making sure that the equinoxes always occur at the right times. Okay, so we actually make winter and fall the shortest month, or the shortest seasons. Summer and spring are longer. Opposite, obviously, in the southern hemisphere, it's opposite. Okay. Yeah, so there's the latitude, okay, has that effect. All right, second biggest factor affecting climate is altitude. The higher up you go, the colder it gets. And it does so by about 6.5 degrees for every 1,000 meters on average. Okay, if you've ever done any mountain climbing, you know that that's true. Okay, it gets colder and the air gets thinner, and that's actually why it gets colder. Okay, the higher up you go. The thinner the air gets, the less it's able to hold on to heat. Okay, the thicker the air is, the better it can hold on to heat. So the higher up you go, the colder it gets, which is why the tops of the mountains have snow on them until June. Okay, even though the snow's been gone here for, 3-4 weeks, probably, for lucky, not like last year, where we had snow till the middle of May. Right? But because it gets colder, the higher up you go, okay, you're going to see that affect climate. So if we're looking at places like Calgary and Vancouver, okay, we don't have a lot of difference in our latitude. We're about the same distance from the equator. But obviously, Vancouver is quite a bit more mild than Calgary is. Okay? And part of that is because it's a lower altitude. The other part of that is because Vancouver is very close to what? The ocean. Yeah, and the ocean has a big effect on climate as well. That'll be the next one of the other factors that we talk about. Okay, but altitude plays a huge role in temperature. Okay, like just in this picture here, which I took probably before you were born. This is a backpacking trip that my dad and I went on. This is Mount Robson here in the background that you can barely see the top of. Okay, and this is taken on July 8th. Oh yeah, you were just. 4 months old. Yeah. Okay, so it's July 8th, right? We were backpacking around Mount Robson, which is the highest point in the Canadian Rockies, right? When we left our campground, which was at about, I want to say about 1,400 meters above sea level, okay, it was about like 15 degrees, and it was a light rain. Okay, as we progressed higher up, okay, when we got to here, this is about 1,000 meters higher than where our campground was. Okay? It was barely above freezing here, right? Which is more obviously than 6.5, but okay, it got a lot colder here, and it was starting to snow. Here at the top of Mount Robson, there was a blizzard, and it was -20 on July 8th. Okay, it's crazy how altitude can affect temperature, right? You see people that climb Mount Everest, okay, they've got all this stuff on, okay, they got all their gear, all their, their down suits and all that kind of stuff because it's cold at the top of Mount Everest because it's so high. Mount Everest actually isn't all that far north, okay, and they do it in the summertime, right? But it's that high up that it's freezing cold, usually -20 to -30, and then factor in the wind, okay, it can be very, very cold the higher up you go. Everybody good with that? Okay, so altitude affects climate. Okay, distribution to land and sea. So the other reason why, Victoria and Vancouver, which aren't that much different in terms of latitude than we are so much more mild. Okay, land gains and loses heat rapidly. Okay, water doesn't. Okay, water retains heat very, very well. Okay, it stays hot for a very long time or stays cold. Okay, without changing its temperature. It can lose a lot of energy, but not change temperature very much. We call that specific heat capacity. It's something we'll talk about later in the unit. Okay, but it has a very high heat capacity, meaning it doesn't change temperature when it loses or gains energy very much. So if I live in Victoria or Vancouver, so I live like over here, okay, I have this huge body of water nearby that is going to regulate my temperature because I'm sharing the air. The air that's over the land in Vancouver and the air that's over the water are touching. So if the land starts to cool off, energy flows from the ocean towards the land by the second law of thermodynamics. Okay, it always flows from hot to cold. So the ocean regulates the temperature of the nearby coastal areas, making them more mild. Okay, everybody kind of follow me there. Now, that's also dependent on the kind of water you have there. Works really well on the west coast where water's quite a bit warmer than it is on the east coast. Okay, there's places on the east coast where the ocean freezes. Okay, if you're over here in Newfoundland and Labrador and places like that, the ocean freezes. Okay, it doesn't do a very good job of regulating temperature once it's frozen solid. Okay, whereas here it stays liquid, right? And that has to do with the ocean currents. So point number 4. Okay, so you can see over here on the west coast that we have what's called the subarctic current, which is like a cold water current, okay, bringing water over towards the coast. But it actually comes from, okay, further out in the ocean and a little bit further south. So it's bringing warmer water here than on this side. Okay, on this side we have what's called the North Atlantic current, which actually comes from the south, but it interacts with these currents here that are coming from the Arctic Ocean under the ice pack. So there's cold water always coming down along the Newfoundland and Labrador coasts, okay, causing that water to be a lot colder, which is why Newfoundland and Labrador gets severe winters, whereas on the west coast, they have very mild winters. Okay, so ocean can regulate temperature, but only to an extent. Okay, for Newfoundland and Labrador, it helps keep the summers from getting really hot. Okay, whereas over here, the summers do get quite hot. All right. Other ocean currents, El Nino and La Nina. Okay, we hear about those all the time. Okay, those are actually currents that form off the coast of Chile. Okay, El Nino is a warm water upwelling. Okay, and there's so much warm water that just comes up, okay, through that current when it happens that it can change ocean temperatures by 2 or 3 degrees globally. Okay, now I know 2 to 3 degrees doesn't seem like much, but when you factor in how much water that is, that's a lot of energy, right? And that can influence then, everybody's weather and climate for that particular year. The Opposite of that is La Nina, and that is when really like kind of Antarctic water comes up and replaces it. That can drop the ocean temperature several degrees and cause us to have a long, severe winter. Felix. The El Nino and La Nina? Yes. When we have a La Nina year, we typically get more northerly winds. We typically get more precipitation. Okay. Yeah. Now, depending on where you are, right? Like El Nino, if you're on the windward side of the mountains, the side where all the moisture hits, that's going to produce lots of snow. For us, it produces almost no snow because that moisture all drops on BC. By the time it gets over the mountains, there's nothing left. We're going to get more Chinooks in an El Nino year because that's how Chinooks form. Okay? But in a La Nina year, we don't get westerly flows. We get northerly flows, which are cold. Okay. What's that? Yeah, and they typically bring, we'll get moisture coming in, but it'll interact with this cold, causing big dumps of snow. If you remember back in 2012, okay, in like 2013 is the year we had the big floods, and we had the big floods because it was the La Nina year. Okay, and it started out in December. We got a snow day. I don't know if you remember that. We don't get those very often, but we got a snow day in December. It snowed like 2.5 feet in 24 hours. Okay, I remember opening up my garage door saying, well, I'll make sure I try and get into work, even though it's a snow day, I'll try and get into work. I opened up my garage door and I just had a wall of snow. Okay, because I lived on the edge of town, right where the wind blew the snow up against my garage. Okay, I had to dig out of the garage. I had piles of snow on the sides of my driveway that were as tall as me. Okay, I shoveled all day. Right? You get that with the La Nina. You get really cold, lots of snow. It's going to be a really severe winter. Okay? Whereas with El Nino, it's going to be hotter and drier. For us, El Nino looks different depending on where you are in the world. Well, it was a mild one. Yeah. Yeah, you know what they keep saying? It's like this year it's a La Nina, this year it's El Nino. They're actually supposed to be on like a 4 to 6 year cycle. So, it's a lot of that whole climate scare you thing, right? Yeah, but it was super hot the summer before too, right? Like this summer wasn't as bad as the summer before. Yeah. It's happening, but not for the reasons they say. Yeah. There's lots of things. I mean, the Earth has cooled and heated over the course of its history many, many times. Okay, I mean, we're on the tail end of an ice age right now, right? And so, I mean, naturally, the warming trend is that it's getting warmer. But is that caused entirely by us? No. Is it caused partly by us? Yes. Okay, but not entirely. There's lots of factors that go into that. Yeah. Okay. All right, so those are the other kind of two big ones, and again, these are going to depend on where you are. Obviously, the nature of ocean currents doesn't affect us. It doesn't determine our climate in any way, shape, or form here. Okay, but the distribution of land and sea does. We're a long way from the ocean. That means we're going to have more wild swings between summer and winter in terms of our climate. Okay, distribution of mountain barriers. That's a big one for us. Okay, where you are in relation to a mountain range can really affect your climate. For us, it means that it's dry. It also means that we get Chinooks. Okay, because if you talk to somebody who's not from Alberta, like Leonardo DiCaprio, okay, about Chinooks, they don't know what they are because they don't experience them. Okay, if you talk to someone who lives in Mongolia and you describe a Chinook to them, they know what you're talking about. Okay, they don't know the word Chinook because that's an Aboriginal word from our part of the world. Okay, they have a different name for it, but it's the same thing. It's describing winds that roll off the mountains that are hot and dry. Okay, and they get them there as well. They just come off the Himalayas for them. Okay, so what happens with a mountain barrier is this. Okay, so if this is BC over here, okay, this is Alberta over here. Okay, we have warm, moist air coming in off the Pacific Ocean. Okay? Flow in our part of the world is generally from west to east. So it pushes this warm, moist air against the mountains, and then it rises up. Well, as it goes over the mountains, it cools off. Okay? And all of the moisture that's in that air condenses and falls as rain and snow on BC, which is why BC is full of forests, okay, especially near the coast where they're like temperate rainforests even. Okay, as you go higher up the mountains, obviously it just becomes kind of, the pine forest and things like that. And then as it gets over the mountains, all of the precipitation has fallen already. So now we have this cool, dry air that's coming down this side. As it comes down, it warms up. And it warms up for a couple of reasons. First off, it's dropping, okay, but also because there's friction against the mountainsides, okay, causing that air to warm up. Okay, so it warms up, but it comes off of here hot and dry. Okay, that's Chinook. We get this hot, dry air that comes off. It helps to melt the snow, dry it up, okay, and lead us to warmer weather. Right? You don't get that everywhere. If you go even, to Edmonton, Chinooks are basically a non-factor. Okay? It only happens kind of down in this area in Montana and places like that. Okay? They don't get them further north. All right. Now, this can also produce a rain shadow. Because this essentially causes moisture to fall on one side and not on the other, what you get is forest on one side and either prairie, grassland, or desert on the other. Behind the Himalayas is the Gobi Desert. Okay? It's not a hot desert. It's a high altitude desert, but it's a rain shadow because the Himalayas are way taller than the Rockies. They block practically everything. All the moisture falls on one side, none of it gets to the other side, and so you have this desert in the back. How many people have ever been to Hawaii? Okay, Hawaiian Islands show this effect perfectly. One side of each island is lush tropical rainforest. The other side is a dry lava bed. Okay, and it's not because the volcano only spills off one side. Okay, it's because the mountains, the volcanoes, are so tall that the moisture all falls out on the one side, okay, before getting to the other. So one side is always going to be dry, the other side is always going to be very moist. Okay, all right, everyone kind of follow the rain shadow effect, okay, because that's an important one for our climate. So we need to be familiar for sure with that one. Okay, and then pattern of prevailing winds is another big factor. Okay, we know all about prevailing winds. The prevailing winds here are from the southwest. Okay, but we can sure tell when we're in for a change in the weather because they change direction and they come from the north. Yeah. Okay, if the wind's not coming from the southwest, it's going to get cold. Okay, very rarely does a southwesterly flow through this area cause cold weather. Right, so we typically get those prevailing winds, okay, from there, but when they change, obviously that causes changes in weather. Okay, and then the locations of high and low pressure. Right, there are some places in the world that typically have low atmospheric pressure or typically have high atmospheric pressure. One of those places is right here. Okay, kind of right underneath Alaska there in northern BC is what meteorologists often call the mother low. Okay, it's a very low pressure area and it rotates and it throws like moist air masses off of it that then travel inland or out to sea, either way. Okay, and then up in here is typically an area of high pressure. Right? When these two things, I mean, they're completely independent of each other, but they can interact right through here. It's Alberta. In fact, some of the worst of it goes right here, right along Highway 2. Okay, we can get that road closed because these two air masses will interact. So the mother low will throw like a big, warm, moist air mass off, and they'll start traveling down this way. Okay. Meanwhile, the Siberian high, that's what this one's called, okay, will throw off an air mass that's very high pressure and very cold. Okay, so when those two things interact, you've got all this moisture now meeting cold air, which causes massive northerly winds, okay, leading to a big blizzard, big snowstorm. Okay, in the summertime, those two things can still happen, except that's when we get a big thunderstorm. Okay, we get the moisture from one, the kind of dryness from the other. Those changes in pressure can rapidly cause thunderstorms to build and get us in a cycle of thunderstorms that we get trapped in. Right, and you can see that that flow kind of continues right down here through. That's Tornado Alley. Okay, so all of those things kind of interact to produce stuff like that. Down in here, it just means that there's like here. Okay, so this is an area where on this particular day, there was a lot of rapid change in pressure. The closer together the lines are, the faster the pressure changes. So this was probably, like what we sometimes get when we get a Chinook, we would get something that looks like that would go right over Alberta, we get that quick pressure change that causes people to have migraines and stuff like that, right? We get that when the Chinook is coming. That's why you see you get the arch. You guys all know what I'm talking about, right? The Chinook arch. Okay, and that's that rapid change in pressure. Okay, when that Chinook arch passes over, suddenly the wind comes up. The wind is the evidence of the pressure trying to equalize. All right. So those are two more. Okay, and then we'll talk about climatograms here. So, okay, climatograms basically only show us two of the components of climate. They show us precipitation and they show us temperature, right? We don't really need to know the other two. This is just telling us kind of some weather patterns about a particular area. So on a typical climatogram, you're going to have two y-axes, right? One y-axis is going to be rainfall. It's typically on the left, but there's no hard and fast rule about that. Okay, the other y-axis is going to be temperature. The x-axis is time, but we go by months. So January, February, March, etc. Okay, all the way along. So each month gets a bar that shows the precipitation, and then there's this line that shows us the temperature pattern. Everybody with me there? Okay, so you might want to make a note here. The line is for temperature. The bars are for precipitation. All right, so what we see here in this one is a place in New Guinea, which is totally a tropical rainforest. Okay, and we see here that the rainfall fluctuates somewhat. There's, obviously it's wetter here during kind of May and or March and April and May. Okay, and then it kind of drops off quickly into September and October, right? But they get in a month 32 centimeters of rain, okay, or even like 27, 28 centimeters of rain. Okay, during these times. Their driest month, they get 11 centimeters of rain, which is still a lot, right? In June of 2013, when we had all the floods, okay, we had 70 millimeters of rain in a week. That's 7 centimeters. Okay, now in a week, I mean that's a lot for this area, right? But still, that's nothing compared to this. Okay, they get 35 centimeters of rain in a month. Okay, if that happened here, we'd have to build an ark and sail away. Okay, because it would just be awful. Okay? But that's why you get a tropical rainforest and not prairie. Okay, if we're looking at Nashville, Tennessee, so that's more of a mid-latitude United States kind of climate, we see that the temperature line now has the shape of kind of a bell curve, which indicates that this place has something this doesn't. Seasons, exactly. Okay, when you see the bell curve, it indicates you're far enough away from the equator, your latitude is great enough now that you're going to get differences in seasons. Okay, in the tropical rainforest, it's pretty much the same temperature all year long. Okay, but as we move away, we see the effect of latitude. Everybody follow me on that? Okay, so we can infer from the shape of these climatograms some of the other factors that are affecting climate. Okay, this shape tells us about latitude. This shape tells us it's near the equator, right? If we go to Anchorage, Alaska, we still see that bell curve. It's almost exactly the same shape, but where is it? Way lower. Okay, and Anchorage, Alaska, even though everyone says, oh, Alaska is so terribly cold, Anchorage, Alaska is warmer than it is here. Okay, because it's closer to the ocean. The ocean regulates it a little bit. Okay, and you can see here, like the coldest month is -10. Okay, it gets colder than that here, right? So just you got to be able, essentially what you're going to have to be able to do with a climatogram is if I put one on a test, you'd be able to tell me where it was from and the factors that affect that climate. Okay, so you'd be able to go, okay, well that that temperature line is a straight line. There's no curve, so it's near the equator. There's lots of rain, so it's probably a tropical rainforest kind of place. Tell me about that place. That's what you have to be able to do from a climatogram. Yeah. Okay, we'll call it there.